Hello there, this is exercise 10E for A-level maths. We're looking at simple trigonometric equations at A-level, going definitely beyond those that you saw at GCSE. So I'm just going to have a look at this now. Now I've got this little starter for you. This really is the GCSE stuff, I suppose. And at GCSE you were meant to be able to solve these kind of equations. You notice the first one says sine x equals 0.2. So if this was me, I'd be saying, well, I'm going to move the sine over to the other side and it will become x equals. Now, what does a sign become? Well, obviously a plus becomes a minus when you move it over to the other side. A minus becomes a plus when you move it over to this other side. A times a divide and a divider times. And these are all just examples really of inverse operations. I suppose a more interesting one is x squared becomes a square root of x. And vice versa, you get the square root of x becomes x squared. And so we should know what the sign becomes, and some people call it sine minus 1. It's really called the sine inverse. It's written with this minus 1 of 0.2. Now if I just do that on my calculator, so the inverse sine of 0.2, you need to make sure you're in degrees. Hopefully I am. Mine says 11.5 degrees, give or take a bit. I say give or take a bit because you can never be perfect on these. Anyway, there's 11.5 degrees. And so I would recommend now you pause the video and do the next two examples, and I'll ping up the answers. So anyway, I hope you did have a chance to do those questions. Here are my answers. Well, I get 11.5, at least that one agreed with what I said. 63.3 degrees and 68.2 degrees. Now let's get on to the main part of this. Now these are, on the face of it, very, very similar. Look at this. It says sine x equals 0.5. And on the face of it, this is almost identical. But it's not quite identical, because the difference is now I'm allowing there to be more than just one answer. So, and if you're not convinced there needs to be more than one answer, I suppose I need to try to convince you. Look, here's the starting point. Comes from the fact that we can still get the first answer from the calculator. So as before, I would go, x is the inverse sine of 0.5, and that is 30 degrees. If you do that on your calculator, you get 30 degrees. 30 degrees. And if I look at the graph of that, that basically comes from this idea. I'm not sure quite why that blue line's a little bit lower than it needs to be. Imagine that's 0.5. That 0.5 line goes across here, and this is 30 degrees. That's the solution. That's where the, if you like, the red sine x graph hits the line 0.5. But you'll notice it carries on going, and it also hits here. And it would actually, the sine graph actually keeps on going and going and going and going and going. It would have hit again over here somewhere. But because they've said at the top, I only want answers between 0 and 360, well, I'm actually only going to find two answers. And by symmetry, you can see that's 30 degrees away from there. So by symmetry, I reckon I can say that that's 30 away from there as well. And so that's why here I've written down this 150 degrees as a second solution. Now, for sine graphs then, we will always be able to do this trick of being able to say, well, I know there's going to be two solutions, and one will be this end and one will be this end. And you'll notice for sine graphs then, we can simply subtract from 180 degrees. We get our first answer, subtract that from 180, gets us a second answer. Notice how we write it though. We have to write them both, 30 degrees and 150 degrees. These are both potential answers. So let's keep going with this, and after a while you might start to see what's going on. So now this is a cos graph this time. So again, I suppose the very first thing I can do is I can say x is the inverse cos of this minus 0.5. And I can chuck that into my calculator and it comes up as 120. And again, I want to look at the graph, because although 120 is a solution, there are more solutions. This is the cos graph, the y equals cos graph. And you can see it goes from 1 down to minus 1 and up again. And then I'm saying when, this is what I'm saying in the equation, you see, it says, when does the cos graph equal minus 0.5? And the answer is it does it here. This is the minus 0.5, and bang, that's where it hits. And so this effectively is the 120 I've got up there. That's 120 degrees. But again, notice the blue line carries on. It carries on to there. And that's a second solution. Now, when I was doing this at A-level many moons ago, we used to basically say to ourselves, well, I can see that it's from the naught line, it's 120 degrees this way. And so by symmetry, from the 360 line, it's another 120 degrees back again. So it's actually 240 degrees. That's what this answer says. But again, after a while, you start to realize, well, first of all, you need to write both answers. Because again, it wants all the answers between 0 and 360. But you start to realize there's a rule. And for cosine graphs, we simply need to subtract our first answer from 360 degrees to get the new answer. There, this is what we do. And these are beginning to sound like a set of rules almost. I've got a cos question now. So we've actually got the cos rule. We just saw it. But 5 cos x equals 2.4. And it says, give me all the values of x such that, oh, look, this is an interesting way to write it. This actually means that x can be between 0 and 360. The only subtle difference is because that one's a square bracket, it can be equal to 360. I don't think it'll matter. It never tends to. Anyway, so I'm looking between 0 and 360 again. I've got 5 cos x equals 2.4. The first thing I'm going to do is I'm going to move the 5 over. And that will give me cos x equals 2.4 divided by 5. So 2.4 divided by 5 sounds like 0.48. 2.4 divided by 5 is 0.48, yes. And that's cos x. And then notice that is cos x. So I want to know what x is. And x, therefore, is the inverse cos of 0.48. So I'm going to press inverse cos of 0.48. And it comes up 61.3 degrees. So that's my first solution. 61.3 degrees. Now notice what I said there. I said that's my first solution. And it's my first solution because I know there's going to be more. And it's because, again, I'm allowed to look anywhere between 0 and 360. I know, for instance, this is the cos graph. It goes like that. And I'm saying, really, when is my cos graph equal to 0.48? Well, I can see a couple of places it's going to hit. By the time it gets to 360, which is there, it will have hit twice. And so last time, you remember, we've seen 2 rules now. Sine, I said you do 180 minus the angle. But for cos, I said, you do 360 minus the angle. So I'm going to do exactly that. I'm going to do 360 minus this 61.3. Well, it sounds very much like it's marginally under. Just make sure I don't make any down mistakes. It's 298.7, of course it is. So my second answer is 298.7. And notice I'm expected to write them both. Okay. So let's put the answer up, 61.3 and 298.7, perfect. Here's one for you to do, it says. Well, I've very kindly drawn you a cos graph here already. Solve to 1 decimal place, that's unusual. Usually it's 3 significant figures, but this one says 1 decimal place. Solve the equation cos x equals 0.4. Well, again, you always need to find what's called the principal solution. So I'll do this anyway. If you want to pause the video, it might not be a bad time to do it. I'm going to do it now. I'm going to move the cos onto the other side. And it will say x equals the inverse cos of 0.4. I have no idea what that is, but I'm going to type it into my calculator. The inverse cos of 0.4. It says 66.4 degrees. X equals 66.4 degrees. But that's only the first solution. Again, this is a cos. We saw cos just now. When it was cos, we knew to do 360 minus my x. So what is my 360 minus my x? 360 minus that number, I've got 293.6. 293.6. Now what's it look like on the picture, just so that we make sure. So it says, when's it equal to 0.4? There's 0.5. So 0.4 is about here somewhere. So I'm just drawing my, this is meant to be a straight line, what we've done with my dodgy pen. So that's my first answer, and I reckon that's about 66 degrees. And I'm saying my second answer is about 293.6 degrees. So, and I've done it to the right number of decimal places by either fluke or design, who knows. So there's my answers. What did I get? Answer here. Oh, I've drawn a graph on top of that. And yeah, that seems about right, doesn't it? Anyway, my answers there are the same. So I like that. And now another one for me to show you, I've said. So let's do this one as well. Now the sine x equals, oh, it's a negative now. Again, this dodgy notation, which we've seen a few times now, answers between 0 and 360. And so this one then anyway, so sine x equals minus 0.25. I can immediately write x equals the inverse sine of this minus 0.25. And I suppose here's the trouble with this one, and this is why I wanted to show you it. If I type this into my calculator, I get the answer minus 14.5 degrees, and that's not even in this right zone. You see, this zone's the interval they've told me to give answers to is 0 to 360, and immediately my answer here is minus 14.5. So you can see the problem here. Now, up here I've written here that you can still get the second answer, and I will still use this formula to get the second answer. It says 180 minus x. So I can get the second answer, no problem, even though that's a bit of a problem. I'll write it over here, in fact. I'll write 180 minus my minus 14.5. What is that? Well, that's obviously 194.5, a minus a minus. So my second answer is actually okay. That's in the interval. My only problem one is the first one. And I don't actually like that one, but I do like the second one. So notice, I think I've got a graph here for you. Let's have a look. Answer. Yeah, minus 14.5 from the calculator. This is my graph, and you'll see the sine graph coming up, coming down, and it hits there. But my problem is, what I found was actually over here. I found this tiny little answer here at minus 14.5. And so what we have to do is just recognize that from here to here, we can always just add on 360 degrees and it will tell me more answers. And if I add another 360 on to any answer that I get, I'll get another answer. And actually I could take 360 off and go the other way as well. So that's what this is all about. It says also add on 360 to get my real second answer. So 194 I liked. The minus 14.5 I add 360 on, and I get this 345.5. Those are my two answers. So that's definitely different. Now here's another equation. It says tan of x equals 2. So I'm going to do this exactly the same way. X is going to equal the inverse tan of 2. And if I do that on my calculator, what do I get? I get 63.4 degrees. Now again, that's only my first solution. It does say here, give me all the solutions between 0 and 360. So again, it's handy to know what the graph looks like. Here's the graph. There's my 63, which I said before. Oh, it said to the nearest degree. But here's my tan graph, you see, which just repeats itself. Every 180 degrees, it repeats itself. So you can always do this now then. If I ever do tan and I get a first solution, the way to get a second solution is just to do 180 plus x. 180 plus x. So effectively, I add 180 onto that, and I get 243.4 degrees. Or if I'm rounding to to the nearest whole number, it's 243. So that's what I get. And here's my rule for tangent graphs: just add on 180. So look, I've got one more question for you to do. You're going to have to be careful of this because it's another one which gives you a negative answer, which will be outside of the range. And you're going to have to use this tan rule, which I've just told you. I'll give you the answers. Minus 27 is the one that is dodgy. See if you can get the other two. And then as a summary then, you're going to try and find what's called the principal solution, the first solution. To get the second solution, you can use this rule. And then you can always do the 360 trick. Add it on, take it away to get other values. Thank you very much.